do an example. So here's our graph. We started out, everybody's false, almost everybody's infinity. Nobody has a predecessor. I didn't put a dash in all of them. Nobody has a predecessor. The important thing is we're going to choose somebody to set to a distance of 0. Now, we did say it's arbitrary. It doesn't matter which one you set to a distance of 0. For simplicity, though, I picked the first one. Why? Because I know there's at least one vertex. I don't want to say set index 10 to 0, because maybe there isn't a vertex 10. So I started with A because it's the first vertex. I know there's at least one. Okay, so this is before the loop starts, this is what the table looks like. All right, got to do this V times. So step 1 is find the smallest false one. So what I'm going to do is I'm going to initialize current distance and current vertex. Before I look at anybody, my best distance so far is infinity. This is where numeric limits double infinity is going to help us. So I say, hey, my current distance is infinity, and I don't even know who it is. All right, so find the smallest false one. So step 1, we go A is false. A has a distance of 0. Ooh, look at that. 0 is better than infinity. So A at a distance of 0 is the best so far. B is false, but infinity is not better than 0. C is false, not better. D, E, F are all false, but they're not better. So step 1 is done. Step 2 says, mark this one as true. Okay, so A gets marked as true, and I'm going to circle it in the graph to remind myself where I am. All right, so we've got that one marked as true. That was step 2. Step 3 says update the false ones. So we go back through the table. I say, well, A is already true. I can't look at it. We can't change it once it's done. So we look to B. B is false. B currently has a distance of infinity. Distance from A, the current vertex to B, is 13. Ah, that's better. So 13 is better than infinity if I use A to get there. Now, what about C? C is false. Currently infinity. A to C is 8. Hey, that's better than infinity. 8 if I use A to get there. All right, D. D is false. Infinity. A to D is 1. That's way better than infinity if I use A to get there. Now, E is false. E's current distance is infinity. What's the distance from A to E? Well, the edge doesn't exist, but think of it as I'm your helper. You're Prim. You call me your helper. You ask me, what's the distance from A to B? I say 13. You say, what's the distance from A to D? I say 1. You ask me, what's the distance from A to E? I've got to give you a double. What do I say? Infinity. I tell you the distance from A to E is infinity. Do you compare it to infinity? No. You say, well, I got a value. Is it better than what's in the table? Nope. Okay, don't update it. You ask me, what's the distance from A to F? I say infinity. You say, is that better than what's in the table? Nope. Leave it alone. So using numeric limits of double infinity makes this really easy to do. Prim doesn't even need to know what's connected to what if Prim has a helper who calculates distances. And the calculate distances will either say 8.0 or 1.0 or infinity. All right, so we're done with step 3. Let's update the graph. So table, what we changed is in red. A has been colored gray because it was easier to see than the red. So we got the changes in the table are in red. A is part of the true set now. Back to step 1. We've got to find a current distance and a current vertex that are the best. Infinity, don't know. All right, so we go through, find the smallest false one. A is true, ignore it. B is false, 13 is better than infinity. C is false, 8 is better than 13. D is false, 1 is better than 8. E is false, infinity is not better. F is false, infinity is not better. Okay, we're done with step 1. Step 2, mark D as true. So D gets marked as true, and I'll circle it up here to show it's in now.
Okay.
All right, step 3, update the false ones. So A is true, leave it alone. B is false. And B is currently false 13. What's the distance from D to B? Infinity. Well, that's not better than 13. Don't update it. All right, how about C? C is false at 8. D to C is 5. Aha, that's an improvement. So 5 if we use, wait, what vertex to get there instead of A? We use the current vertex. I'm just going to rewrite my 5 there. It was a little illegible. So 5 if we use D. All right, D is true. We can't change it. E is false, infinity. Distance from D to E is 4. 4 is way better than infinity. So 4 if we use D as a predecessor. All right, F is false. Infinity is the current distance. D to F is 5, better than infinity, if we use D as the connector. And again, I'm writing a terrible 5 down in the corner. Let's make that look a little bit more legible. Oh, it shouldn't matter because, hey, we're done with step 3. Update the slide. Okay, so we've got red ones are changed. A and D are both in. We've got to go back to step 1. Find the smallest false one. Yes, question.
Like previously when you compare like D to B, and you said it was like infinity, like how do you know that like from the table?
Oh, well, see, there's no edge in the graph from D to B.
You just check if there's no. Okay.
Yeah, we check if there's no connection between them, the helper would say infinity.
Oh, okay.
Yep, so it all comes down to, is there a graph? And that could depend on like a distance matrix or just a calculation that we do on the fly. However the helper does it, the helper determines there's no edge from D to B, I answer infinity. Okay, so we start out, whoops, almost caught it. All right, so we start out, we've got a distance of infinity because I haven't looked at anybody yet. Step 1, find the smallest false one. A is true, can't look at it. B is false, and 13 is better than infinity. Oh, wait, just 1 second here. Just 1 second. I want to do one change before we finish this slide. What if E had a distance of not 4? What if E was 6? Now, I have to pick the smallest false one. I could either pick C at 5, or I could pick F at 5. Does it matter? Well, they would both be equivalent, right? I could pick one or the other. So the order that I pick them doesn't matter. I would probably end up picking C just because I get a 5, and then 5 is not better than 5, so I stick with C. But it just doesn't matter because this is a place where we might have both of them get kept anyway. Maybe one gets kept and the other doesn't, and we have an equivalent MST. Now, the neat thing about Project 4 on the auto grader is something that's different about it from every other project. So part of every project is a program called the judge. And the judge judges your answer correct or not. Up until now, the judge for everything has been, do you have the same output as us? Then it must be right. In Project 4, what the judge does is it says, okay, let me look at your output, let me look at the original input, let me look at the correct output, and let's see if what you gave me is a valid MST. Is your cost right? Do the edges that you listed add up to the same total you reported? Do the edges you listed produce a tree without any cycles? Is everybody in? Is nobody cycled? Then, oh, look, that's a valid answer. So in Project 4, every one of these parts has a different judge, and as long as your output is valid, you get it right. It doesn't have to be the same as ours. All right, so that's what the answer here is. If E was a distance of 6, or even if E was a distance of, let's say, 5, and now I've got one of 3 5s to pick from, it still doesn't matter which one I pick, I'm going to end up with equivalent MSTs anyway. All right, so I just wanted to do that little aside while we were at this point before we moved beyond it. Okay, so we're in the middle of finding the smallest false one. So we get to B was 13, C is false, C is a distance of 5, that's better than 13. All right, D is true, can't look at it. E is false. Distance of 4 is better than 5. So 4 if we use E. F is 5 is not better than 4, so we don't use that. And we're done with step 1. Step 2, we've found our best one. We mark E as true, and I'll circle it there to remind myself where I am. Now, step 3 says update the false ones. Well, A is true, can't update it. B is false 13. What's the distance from E to B? No edge exists, must be infinity. Oh, infinity is not an improvement over the 13 we have, we ignore it. All right, C is false. C is false at a distance of 5. E to C is 3, that's better than 5. So let's update the table. So distance of 3 if we use E to get there. D is true, can't update it. E is true, can't update it. F is false at a distance of 5. E to F is 2, that's better than the 5 in the table. So we'll update that to 2 and the predecessor to E, the same as the current vertex. All right, step 3 is done. Changed slides. All right, so we've got to go back through current distance, current vertex. Starts out with infinity and I don't know. Let's find the smallest false one. A is true, not A. Can't look at it. B is false. 13 is better than infinity. So 13 if we use B. C is false. 3, oh, that's better than 13. D is true, can't look at it. E is true, can't look at it. F is false, but 2 is better than 3. 2 if we use F. All right, so step 1 is done. Step 2, mark that one as true. So F is true, we'll circle it over there. All right, step 3, update the false ones. A is true, leave it alone. B is false, 13. F to B is infinity, not an improvement over 13. All right, C is false. Cost of 3, F to C is infinity, that's not an improvement over 3, don't update it. D is true, E is true, F is true, can't update them, we're done. Move to the next slide. All righty, we gotta find the current distance, current vertex. Starts out with infinity and don't know. All right, so let's find the smallest false one. A is true, can't look at it. B is false, 13 is better than infinity. C is false, 3, whoops, I put a C there. So C is false with a distance of 3, so 3 is better than infinity, or sorry, 3 is better than 13. D is true, E is true, F is true. All right, we found the smallest false one. Mark C as true. And there we go. Now, step 3, update the false neighbors. Well, update anyone who's false. We check them all. A is true, can't change it. B is false at 13. C to B is 15. That's not an improvement, so we leave it alone. C, D, E, and F are all true. We can't update anybody who's true, so we go back through the outer loop. Step 1. Find the smallest false one. Infinity, don't know. A is true, B is 13. That's better than infinity. C, D, E, and F are all true. They're not candidates. All right, step 2, mark B as true. Update the false ones. Well, true, 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 true. Nobody to update. We're done with step 3. And that's our final graph.